Hi guys, Dr. Diaz here again, and you remember we were discussing a moment ago one of these integrals. I'm gonna do it again because that campus thing failed miserably, and the video, the whiteboard I was using, we couldn't see well that problem. So let's go with this one, the one that it says the integral of b to the x dx. Well, if you remember in that occasion, I said, the way we solve these integrals is look into this type of integral, the one that says e to the u du, which is equal to e to the u plus c. Yeah, good. And why I want that, why I want to use this type of integral, because it's actually much easier to solve the problem. So what we have to do, we have to somehow turn this thing into something like e to the u. And if you remember, one of the rules of exponential logarithmics says that e to the natural log of, let's say, of x is equal to x, right? The same as a natural log of e to the x is equal to x, and the reason is because e and natural log, they are inverse function to one another. So how we change this b to the x? Well, here we go. This b to the x might look like something like this, b to the x. So what we do that this be equal to b to the x? Well, look, this expression we have here, we can put a general expression will be like e to the natural log of f of x is equal to f of x. In this case, f of x is b to the x, so let's say f of x being equal to b to the x, and then in this case we will have what? E to the natural log of f of x, it will be equal to what? E to the natural log of b to the x. Aha, right? Because we call f of x b of x, we put it back in the function, the expression, and then we got this thing. And the way we're going to solve this one is not with this b to the x here. We're going to solve this one dropping the x and having e x natural log of b. Now this integral is much easier to solve. Aha, so let's go. Let me scroll this one a little bit down. So this is what we have. The integral of b to the x dx is equal now to the integral of e to the x natural log of b of the x, right? Because you remember we did this change here, we put the b to the x equal to f of x, we used one of the rules of exponents and logarithmic functions, and okay, voila, we use this one here. Now here we said that u be equal to x natural log of b. So the u is going to be equal to what? Well, this is going to be the derivative with respect of x of what? Of x natural log of b, and we know that this is going to be what? The u is going to be equal to what? Natural log of b dx. But here we said in this one as u, this is going to be dx, so then we solve here for dx, and we will have that the u divided by natural log of b is equal to dx, right? Now we have the dx. Our dx is going to be what? The u natural log of b. Now substituting these fellows here back to the integral, we will have something like this. This integral turn into integral of e to the u times du, right? But this e to the u is going to be the integral of, times du, right? But the u, wait. Let's go back a little bit. This du is not the u. This du is the u divided by natural log of b, because we're substituting with the x for the u, right? So we have to put natural log of b. So now we go here, e of u divided by natural log of b du. So we take the natural log of b out. Let me roll this a little bit. Okay, now we're taking the natural log outside the integral because it's a constant. It doesn't have an x, so we can take it out. We have integral e du du, and everybody remember that integral e du du is what? E to the u plus c. So this will be 1 over natural log of b e to the u plus c. But remember that we set u, remember what we call u? U was what? X natural log of b, which actually if you put the exponent up here, this is the same as what? Natural log of b to the x. And you can write that one, it doesn't matter because we already called u. Look here, up here we're saying u is equal to x natural log of b. You say it right here. So this one here. Yeah. Okay, then we go here, and remember we're still solving this integral. B to the x dx is equal to what? 1 over natural log of b e to the natural log of b to the x, right? Because it's this same, but then you can put the exponent here in b, and you have what? Natural log of b to the x plus c. And if you remember the definition by exponential, e to the natural, well, e to the, let's put natural log of f of x, and I'm sorry, there's another variable here. Okay, I fix it. E to the natural log of f of x is equal to f of x is one of the rules we have up there. Then this part is going to be equal to what? E to the natural log of b to the x is just going to be b to the x. So our integral, let me roll this a little bit down. Our integral, that it was b to the x dx equal to 1 over natural log of b to the x is equal to what? Bx, b to the x plus c. Aha! So if you want to write it nicely, everybody can see this. This is equal to what? Bx, natural log of b plus c. Yay! And here is the integral. I hope this is more clear than the one we did a moment ago. Let me try to do one of the other problems we have there. Well, actually, okay, I'm going to do now another one in a second. Okay, we already solved the first one. Let's solve this one that also I tried to do it in that whiteboard on canvas. Alright, so let's look here. This one says integral of natural log of x squared dx. This one you have to do it by integration by parts. And well, how we start? Well, let's say let u be equal to natural log of x squared. Du is going to be, what's the derivative of this? You drop the 2, you leave the natural log alone, and now you do the derivative of natural log, which is 1 over x, right? So this one would end up being something like 2 natural log of x divided by x. Now, we select here u, and this is du, which is dx. I forgot the dx. Now we have to select who is going to be our v. And dv, I'm sorry. dv is going to be actually dx. So v is equal to x. Simple, right? Yeah, sure. So here we go. Yeah, sure. Okay, natural log of x squared dx is going to be equal, and if you remember, I'm going to put the rule here. The integral of u dv is equal to uv minus v, the integral of v du. And this is the integral we're going to use. This is the integration by parts. So in this case, who is v and who is u? We have v is x, right? uv, and u is natural log of x squared minus the integral of who is v, x, here it is, and who is du. Du is going to be times 2 natural log of x divided by x dx. Perfect. Now you can see this x and this x cancel, so then this integral end up looking like this: x natural log of x squared minus the integral, we can take the 2 outside because it's a constant 2, and then what we have is natural log of x dx. And I thought I already solved this integral natural log of x. I'm going to roll this a little bit up. I thought I already solved this type of integral. If not, there is actually another, well, this is one of those problems also very difficult to solve. How we solve the integral natural log of x? Well, the first thing you say is let u be equal to natural log of x, and then du, what's the derivative of natural log? Is 1 over x dx. dv is going to be equal to dx, and when you integrate v is going to be v is equal to just x. The integration of dx is going to be x. Aha! So now we go here, and for this part we're going to do the same thing. We're going to use the same integral of integration by parts, the one that says u dv is equal to uv minus v du, right? We're going to use again the integration by parts formula, right? Perfect. This part is already solved. We don't need to do nothing there. So here we go. Let's write this thing again. It's going to be x natural log of x squared minus 2 times, okay, what's going on here? First, who is v and who is u? Well, v is x, u is natural log. And if I remember when I said in the video, don't put natural log of x and then put times x here, because then you might get confused and you think it's going to be x squared. Put the other x in front of it. Because even though this is v, let's put it anyway, they're multiplying each other. It's x natural log of x minus the integral, another integral, who is v? V is x, and who is du? Du is 1 over x dx. And look what's happening here. X and x cancel, and then you have only the integral dx. Let me roll this a little bit up. Now, doing that, you will have this. Let's keep going with this one. This one is going to be x natural log of x squared minus 2x natural log of x, and then the 2 and the negative 2 is going to be plus 2. The integral of the x and the integral of the x is going to be x. So at the end, the integral of natural log of x squared dx is equal to x natural log of x squared minus 2x natural log of x plus 2x plus c. Forget the constant of integration. There it is. Okay, this was the problem that I was trying to solve a moment ago, and I think I did not do a good job there, because you can barely see what I was writing in that whiteboard. Alright guys, I hope this helped a little bit. I'm going to do the third one in a second. Okay, let me do it in a second.